Hello again, this is Dr. Mike Cochrane with Value Function Analytics, and today we're going to continue our modeling climate change policy decisions using a decision tree video. This is part two, and today we're going to talk about sensitivity analysis. But before I get into that, I just want to recap where we left off the last time. Notice that these are all the model outcomes on the left-hand side, all six of them. And note that the policy responses or solutions can be combined. Note that the defensive solutions approach applies to both the outcomes of reducing human activity not being able to fix the problem and the fact that we can't stop global warming. And together the probability score for that is 0.44, which suggests that that's the approach that we should take. The two responses in which global warming was not really a problem, or the outcomes rather, where global warming was not really a problem and the Earth is not warming, those didn't require a response, so we could combine those. So what we're looking at then is the breakout of the possible strategies or policy responses. And so we're going to have to do some sensitivity because we know that the 0.44 is pretty close to the 0.36, which would then mitigate toward a different policy approach. So let's do a sensitivity analysis on this. And when we do that, we're going to use the goal seek function in Microsoft Excel. That's in the Data Tools menu. We're going to use it to explore sensitivity, first of all, for event number 4, possible outcomes. And we are going to set the terminal probability score for current policy approaches to 0.4 and let the goal-seek algorithm find the corresponding probability distribution for event 4, which is reducing human activity fixes the problem. This is event 4 right up here. And the model outcome reducing human activity fixes the problem must have an assigned probability of 0.55 or higher, remember, for the current policy approaches to equal or exceed the scores for defensive solutions, assuming all other probabilities in the model are held constant. So let's see what that looks like when we vary the sensitivity analysis on event 4. This is pretty clearly seen in the interaction or the intersection of these two graphs. This graph shows that these two general policy approaches are highly sensitive to changes in the probability that reducing human carbon dioxide emitting activities also reduces global warming. In this chart, the sensitivity is across the bottom here, where we can vary from 0.1 to 0.9 the probability associated with event 4. And the resulting outcome probabilities are in the vertical axis. So you can see that here's the 0.55 at which the point they intersect. So if event 4, that reducing human activity fixes the problem, if we're more certain of that, if it goes higher than 0.55, then you can see that current policies in the blue would be the way to go rather than the defensive policies. So this is one of the examples where we can see the value of doing the sensitivity analysis. We did a sensitivity analysis on event 5, but here we see that the degree of sensitivity is really not quite the same. In fact, current policy approaches is completely insensitive to changes in the assigned probabilities for event 5. This is because the defensive solutions policy is also the appropriate response for the outcome in which global warming cannot be reversed, given that human activity is not a primary contributor. Let's take a look at event 3, which is the primary cause of global warming to begin with is human activity. You can see there's some movement in these two curves, but the movement doesn't intersect in any way until you get basically to certainty beyond 0.9. As with event 5, this model is insensitive, essentially, to changes in this event probability across the range that we're looking at. Varying the probabilities of events 1 and 2 has no bearing on the relative movement of the outcome probability scores we've been observing. And this is because any change in these probabilities is going to be applied uniformly across all of the event probabilities downstream from these nodes. So what can we conclude? The degree to which reducing anthropogenic CO2 forcing correspondingly retards global warming turns out to be the major driver of policy solutions. Our model shows that it does not matter whether human activity is actually the primary cause of global warming. We, as you recall, assigned it a 90% probability, which was pretty worst casing it. The currently advocated global warming or global environmental policies exemplified by the Kyoto Protocol or cap and trade laws assume that there is a deterministic relationship between global warming and CO2 forcing that operates in both directions. In other words, if humans caused it by their activity, they can also uncause it by reducing or ceasing that activity. And this may not be the case. Our modeling effort shows or suggests that we must be at least 55% certain that reducing human activity will also cause a corresponding reduction in global warming before we even consider the current regulatory policies advocated by the environmental movement. And it should be not overlooked that even assuming a model heavily weighted toward problematic global warming caused by human activity, there's still an almost 20% probability that warming is either not happening or won't be a significant problem if it does. The costs of policy solutions undertaken to deal with the threat of climate change are going to be massive and will entail both monetary and non-monetary costs to society. Such high costs demand a correspondingly high degree of certainty regarding the likelihood of possible future scenarios. In particular, the scientific community must be able to show, with a very high level of confidence, that reducing or ceasing human activity associated with greenhouse gas emissions will reverse global warming. If this is not possible, in other words, if it can't be demonstrated to a sufficient degree of certainty, then policymakers should assume that global warming is essentially unstoppable and consider defensive measures as the most prudent policy approach. Well, I hope you've enjoyed this little exercise in how to use a decision tree to do policy analysis. It's an interesting exercise because it systematically walks you through questions that need to be asked sequentially and allows you to experiment by assigning probabilities to the outcomes of those questions so you can explore different future potential scenarios. And I hope you see how we were able to use very broad general strategy or policy responses to the outcomes and then assign probabilities scores to those based on how we assigned the probabilities associated with the nodes in our decision tree. So if you have any questions about this, please, you can see the email there. Email me at valuefunction@gmail.com or go to my website, which is valuefunctionanalytics.com, and we'll see you next time on Value Function Analytics.